Hello students, I am Bhavesh sir, and in this lecture we will cover following topics from the chapter Ray Optics. Okay, so the topics are: first topic is phenomena of refraction of light, and in phenomena of refraction of light we will go through the following topics also: subtopics, types of medium, terms related to refraction, laws of refraction, and then some important cases. Now after that we'll take the second topic, and second topic is apparent depth. Okay, in apparent depth we will study two cases means first is when the object is placed in denser medium, and second case is when object is placed in a rarer medium. Okay, now after that we'll take third topic, and third topic is total internal reflection, and in total internal reflection we will study about the critical angle. Okay, then after that fourth topic is refraction through spherical surface, and the last topic fifth is lens maker's formula and power of lens. Okay, so these are the all topics from which we will all these topics we will study. Okay, so let's start with the first topic, and first topic is phenomena of refraction of light. Okay, so phenomena of refraction of light. Before studying about what is refraction of light, how we can define the refraction of light, let's see about the medium. What are the types of medium? So the types of medium we already studied in the chapter reflection of light. What is a medium? How we can define the medium? So medium is a substance from which the light ray travels. Okay, medium is what? Medium is a substance from which light ray travels. So, and we can classify the medium into three parts. First part is called transparent medium. Second is called translucent medium, and third is called opaque medium. Now, what is a transparent medium? Transparent medium is a medium from which light ray travels. Okay. In case of a translucent medium, the part of light ray travels, and in case of a opaque medium, the light ray does not travels through that medium. Okay. Now here I am taking only transparent medium. Okay, because that transparent medium will help to understand the phenomena of refraction of light. So let's see here, transparent medium. Transparent medium. Okay, so this transparent medium here in this chapter we can classify into two parts. Okay, let's see here. So we can classify this transparent medium into two parts. The first part is called rarer medium. First part is called rarer medium. Okay, and second part is called denser medium. Okay, so this transparent medium we can classify into two part. The two parts is first is rarer medium and second one is a denser medium. So here we have a term which is called optical density. What is a term? Optical density. Now what is optical density? Like we know that the speed of light is maximum in vacuum or air, and the value of speed of light in vacuum or air is 3 into 10 to the power 8 meter per second. Okay, so when the light ray travels from air to any another medium or any other medium, like for the transparent medium I can have the following example. We know that air, glass, water, okay, etc. These are some examples of a transparent medium. Let's say the light ray travels from air to glass. Okay, so when the light ray travels air to glass, what happens? The optical density of glass is much more than the air. Okay, so and what is optical density? Optical density is the ability of a material to I can say that restrict the speed of light or restrict the motion of a light. Okay, so where because the optical density of a glass is more than the air, so what happens? Because the optical density of a glass is high as compared to air, so that it restricts the motion of the light within a glass. Okay, so I can say if the optical density is more, then the speed of light will decrease, and if the optical density is less, okay, if the optical density is less and when the light rays travels from one medium to another medium, okay, and the optical density of a particular medium is less as compared to air, okay, so if optical density is less, then speed of light will be speed of light will be more. Okay, so now here I can define the rarer medium. What is a rarer medium? It is a medium whose optical density is less, and because its optical density is less, the speed of light in this medium is more. Okay, now let's define the denser medium. Now in case of a denser medium, the optical density of that particular medium, okay, optical density of this medium is more. Now because optical density is more, so that speed of light in this medium is less. Okay, now let's to understand this about rarer medium and denser medium, let's take an example. And in that example, let's say I have a medium like there is a air and here is water. Okay, and this is a interface. This is an interface. Now, what is an interface? Interface is a surface which separates the two media. Okay, so let's say the light ray is traveling from air to water. Now, if I compare air and water, the optical density, like I am comparing these two medium. Okay, so because optical density of air is less as compared to water, so that the speed of light is more in air. Okay, here optical density of water as compared to air is more, so speed of light will be less. Okay, so I can say that if I see these two medium, so air is a rarer medium and water is a denser medium. Okay, understand? Now let's take another interface. Let's take an interface of water and glass. Okay, let's say there is water, first medium, and second medium is glass. Okay, now if I compare both these medium, so optical density of water is less than as compared to glass. Okay, so the speed of light will be more in water as compared to glass. Okay, now in case of a glass, if I compare it with water, so optical density of glass is more, and because optical density of glass is more, so that speed of light will be less. Okay, now, in this case, I can say that water is a rarer medium and glass is a denser medium if I compare both these mediums. So I hope you understand the concept of rarer medium and denser medium. Okay. Now let's move to next topic. And next topic is refraction of refraction of light. Okay. So now to understand refraction of light, let's see here. Let's say this is XY. This XY is a interface. Okay, what is this? This is XY. This XY is a interface. And what is interface? I just define it. What is interface? Interface is a surface which separates the two media. Okay, let's say here is a medium one, and this one is the medium two. Okay, so this surface XY is separating two media, one and two, so this is called interface. Now on this interface, let's take a point O. So this is the point O. So this point O is called point of point of incidence. Okay, this point is called point of incidence. Okay, now on this point of incidence, let's draw a line like this. Okay, so this is a imaginary line which is passing through point of interface. And okay, so this is the imaginary line. This line is an imaginary line which is passing through the point of incidence and perpendicular to the interface XY. This line, this line and dash, this line and dash is called normal. Okay, this line and dash is called normal. So this is the imaginary line which is passing through the point of incidence and perpendicular to the interface XY. Okay, now let's see here. So this is the light ray. Let's say this point, this is AO. Okay, this AO is called incident ray. Okay, And how we can define the incident ray? Incident ray is a light ray which falls on an interface at a point of incidence. Okay. Now this incident ray AO making an angle I with a normal. This I. Okay. So this I is called angle of incidence. Okay. This I is called angle of incidence, or I can define this angle of incidence that it is an angle between the incident ray and the normal. Now, as we know by the property of light, that light rays always travels in a straight line in a particular medium. Okay, so by knowing this, property of a light, I can say if there is no interface, then this light ray can travel like this. Okay, but what happens the optical density of both the mediums is different. Okay, the optical density of medium 1 is different and optical density of medium 2 is different. So when the light ray travels from medium 1 to medium 2, as I explained before when I was defining rarer medium and denser medium, that the speed of light will change. Now, because the speed of light changes, so that this light ray will bend. Understand the concept? What is a concept? When the light ray travels from one medium to another medium of different optical densities, its speed changes, and because its speed changes, it bends like this. Let's say like this, it bends. It bends from its path. Okay, and this phenomena of bending of light is called this phenomena of bending of light is called refraction of light. Let's say this point is B, and okay, so this OB is what? Refracted ray. Okay, this OB is called refracted ray. Okay, and this angle which refracted ray is making with the normal is called angle of refraction. So R is called angle of refraction. Okay. Now I can define the phenomena of refraction of light. What is the phenomena of refraction of light? When the light ray is traveling from one medium to another, okay, when the light ray travels from one medium to another of different optical densities, it bends. Okay, it bends, and this phenomena of bending of light is called refraction of light. Okay, this phenomena of bending of light is called refraction of light. I hope you all understand the concept of refraction of light and why the refraction happens. Okay, why the refraction happens? Because the optical densities of both the medium is different, and because of the different optical densities the speed of light changes, and because the speed of light changes it bends. Okay, now let's move to next topic, and that topic is laws of refraction. Okay, so what are the laws of refraction? So the first law or the first point of this law is of laws of refraction, the incident ray. So in my ray diagram, what is incident ray? AO. Okay, incident ray, refracted ray. So what is a refracted ray here? Refracted ray is OB. Okay, so incident ray, refracted ray, and normal. So here normal is what? N dash. So the first law is incident ray, refracted ray, and normal all lies in a all lies in a same plane. Okay, all lies in a same plane. Understand? You can see this diagram. If I consider this screen as a two-dimensional screen, okay, as a two-dimensional plane, obviously it is a two-dimensional plane. This is horizontal axis, this is vertical axis. So you can easily understand that this incident ray, this refracted ray, and normal all lies in a same plane. Okay, now the second law or the second point of this laws of refraction, the second point is the sine of incident angle. So I can write sine I, or I can say that the ratio of sine of incident angle to the sine of refracted angle is always remains constant. Okay, the ratio of sine of incident angle to the sine of refracted angle is always remains constant. Okay, so this is the second point of the laws of reflection. Now this point, or this is also called Snell's law. Okay, this is also called Snell's law. Okay, now let's see some cases. Okay, so some special cases. Okay, so in some special cases, let's take the first case. And what is happening in this case? The light ray is traveling from rarer medium, rarer medium to denser medium. Okay, actually, I am making some statements. Like I am making a statement that when a light ray travels from rarer medium to denser medium, it bends towards the normal. Okay, what I am saying that when a light ray travels from rarer medium to denser medium, it bends towards the normal. And when the light ray travels from denser medium to rarer medium, it bends away from the normal. Okay, so I'm making these two statements I made. So let's prove these statements by the mathematical expression. Okay, now before going to prove uh, these two statements mathematically, we have to, it is very important to know about the refractive index. Okay, it is very important to know about the refractive index. Now what is the refractive index? So refractive index for a particular medium tells us that how much the speed of light, how much the speed of light increases or decreases in a particular medium. Okay, now refractive index is having two types. The refractive index is having two types. The first type of refractive index is called absolute refractive index. What it is called? Absolute refractive index. Okay, absolute refractive index. So let's take this ray diagram again. So this is my medium one. Okay, so how we can define the absolute refractive index? Absolute refractive index is the ratio of speed of light in vacuum or air divided by speed of light in a medium. Okay, the absolute refractive index is a ratio of speed of light in a speed. It is a ratio of speed of light in a vacuum or air divided by the or speed of light in a medium. Okay, as we know that the speed of light in a vacuum or air is, we are taking it as 3 into 10 to power 8 meter per second. Okay, so this c is constant. Now because this c is constant, I can easily say that mu is proportional to 1 upon v. Okay, mu is proportional to 1 upon v, and from this relation I can say that if the refractive index increases, the speed of light, the speed of light decreases. Okay, if the refractive index of a particular medium increases, okay, then speed of light decreases. And when the speed of light decreases, speed of light decreases when the optical density is higher. So I can also say that if the optical density of the particular medium is higher, okay, if the optical density of a particular medium is higher, then the refractive index is also higher, and because the refractive index is higher, the speed of light will be lesser. Understand? So let's say this is my medium 1, and in this medium 1 the speed of light is v1. Okay, so now I can define, or I can write the relation for the absolute refractive index for this medium. Okay, I can write the formula of absolute refractive index for this medium 1. So it will be equal to c divided by v1. Okay, let's say the speed of light in this medium 2 is v2. So I can write the absolute refractive index for this medium 2 as c divided by v2. Understand? So this mu1 is a absolute refractive index for this medium 1, and mu2 is the absolute refractive index for medium 2. Okay, and let's say the lambda 1 is a wavelength of light in this medium 1. Okay, and lambda 2 is the wavelength of a light in medium 2. The frequency remains same. Okay, the frequency in both the mediums remains same. So let's say the frequency is f here and frequency is f here, it remains same. Okay, because the frequency depends on the source of a source of a light. Okay, so that the frequency remains same. So what I just tell you that, all of you, that v1 is a speed of light in medium 1, v2 is a speed of light in medium 2. The absolute refractive index is the ratio of speed of light in vacuum or air divided by speed of light in a medium. From that I can write mu1 is equal to c by v1 and mu2 is equal to c by v2. Lambda 1 is a wavelength of a light in medium 1, lambda 2 is a wavelength of a light in medium 2. The frequency remains same, ff. So this is the absolute refractive index. Okay, now let's define the second type of refractive index, that is called relative refractive index. This is called relative refractive index. Okay, now what is the relative refractive index? Relative refractive index we can write like, here what is happening, the light ray is traveling from medium 1 to medium 2. So I can write that relative refractive index of medium 2 with respect to 1. Okay, what is happening here, the light ray is traveling from medium 1 to medium 2. So I can write the relative refractive index as relative refractive index of medium 2 with respect to 1, and it is equal to sine I divided by sine R, and it is equal to V1 divided by V2. As we know, V is equal to F lambda, so F lambda 1 divided by F lambda 2. So cancel out this through this, so I will get this relation also, lambda 1 divided by lambda 2. Okay, so this is the relation for the relative refractive index when the light ray is traveling from one medium to another. Let's say according to this ray diagram, the light ray is traveling from medium 1 to medium 2. So I write just the relative refractive index of medium 2 with respect to 1 is equal to sin I by sin R, and it is equal to V1 divided by V2 and then lambda 1 divided by lambda 2. Okay, so I hope now you all understand that what is the absolute refractive index and what is the relative refractive index. Now let's move to our cases. Okay, so this is the first case. So again I'm repeating my statement. So I just said that when the light ray travels from rarer medium to denser medium, it bends towards the normal. When the light ray travels from denser medium to rarer medium, it bends away from the normal. Okay, so let's see here mathematical expression of these two statements. So rarer medium to light rays traveling from rarer medium to denser medium. So let's say in rarer medium, the speed of light is v1, and in denser medium, the speed of light is v2. Now we know that the speed of light is more in rarer medium as compared to denser medium. So I can say that V1 is greater than V2. Now if V1 is greater than V2, I can write V1 divided by V2 is greater than 1. Okay. Now from just I explained you the relative refractive index. So I can write that sin I divided by sin R is greater than 1. Okay. From here I can say that sin I is greater than sin R, or I can say that I is greater than R. Okay. So what is happening when the light ray is traveling from rarer medium to denser medium? The incident angle of incidence is more than angle of reflection. So if I draw a ray diagram for this case, let's say this is interface again, and this is normal, and let's say this is my incident ray, just fall on it like this. So this is the incident ray. Now this incident ray is making an angle I. So this is an angle I. Now if in this case the I is larger than R, so what happens? This light ray bends like this towards the normal. This light ray bends towards the normal. And because it bends towards the normal, you can see here that the angle I is more than R. So now I can say that when the light ray is traveling from rarer medium to denser medium, it bends towards the normal. Okay, now let's see the second case. So so in second case, what is happening, the light ray is now traveling from denser medium. The light ray is now traveling from denser medium to denser medium to rarer medium. Okay, the light ray is now traveling from denser medium to rarer medium. Now let's say the speed of light in denser medium is v1 and speed of light in rarer medium is v2. So we know that the speed of light is more in rarer medium as compared to the denser medium. So I just write v1 or v2 is greater than v1. Okay. So from here I can write v1 divided by v2 is less than 1, and then this v1 by v2 we can write sine I divided by sine r, okay, is less than 1. And from here I can write sine I is less than sine r, or this I is less than r. Okay, now what is happening when the light ray is traveling from denser medium to rarer medium? The angle of incidence is lesser than angle of refraction. So let's draw a ray diagram for this case also. So this one is a interface. This is normal again. Okay. Now draw a incident ray. So this is an incident ray like this. Okay. So this is an incident ray and this is the angle of incidence. Now in this case the I is less than R. So the refracted ray will go like this. It will go away from the normal. Okay. It will go away from the normal so that the R becomes larger than I. Okay. So when the light ray is traveling from denser medium to rarer medium, it goes away from the normal. Okay. So let's see two more cases. Let's see two more cases, like third case. In third case, what is happening? The light ray incident normally, or I can say normal incidence. Okay. So let's see what is happening in case of normal incidence. So this is an interface and this is normal. Okay. So normal incidence means the incident ray comes like this and falls on the interface at the point of incidence. So in this case, you can see that I is equal to 0. Okay, the I is equal to 0. And I can write that like this is my medium 1, this is my medium 2. Okay, so I can write that mu 2 1 is equal to mu 2 divided by mu 1 is equal to sine I divided by sine r. Okay, from here I can write that sine r is equal to sine I into mu 1 divided by mu 2. Okay, so mu 1 and mu 2 are the absolute refractive indices for medium 1 and medium 2 respectively. Now from here, because I is equal to 0, so it becomes sine 0, okay, into mu 1, okay, mu 1 divided by mu 2, and here sine r. So you can see from this you will get r is equal to 0. So the r angle of refraction comes 0. So because angle of refraction is 0, what happens? This light ray will go straight like this. Okay, and r will be equal to 0. So this is also an important case. Okay, so when the light ray incident normally, then the angle of incidence is 0 and the angle of refraction is also 0. It will go straight like this. Okay, now let's take its last case, fourth case. Now fourth case is if we have the mediums and the absolute refractive index of both the medium is same. It means mu1 is equal to mu2. Let's say it is mu. Okay. So what I can write, mu21 is equal to mu2 divided by mu1 is equal to sine I divided by sine r is equal to v1 divided by v2. Okay, now because mu2 and mu1 is same, mu2 and mu1 is equal, so I will get sine I divided by sine r is equal to mu2 by mu1. Okay, we cancel out these two, so we'll get I is equal to r. And also I can say that v1 upon v2 is equal to mu2 upon mu1. So we cancel out these two, you will get v1 is equal to v2. So what is happening if the refractive index is same? Okay, if the refractive index of both the medium is same, then there will be no refraction. Okay, so this is the case of no refraction because the value of I will be equal to R and there will be no change in speed. So when I started this topic, I just tell you that what is the phenomena of refraction of light. Refraction of light means when the light ray travels from one medium to another medium of different optical densities, its speed changes, and because of the change in its speeds, the light ray bends, and this bending phenomena or this bending of light is called reflection of light. Now, in this case, there is no change in speed, and because there is no change in speed, so there will be no bending, and because there will be no bending, so I can say there will be no refraction. Okay, so this is all about our first topic, and that first topic is from here you can see that that was our first topic, phenomena of reflection of light. So we have covered all the subtopics like types of medium, terms related to refraction, laws of refraction, and important cases. Okay.